Rafikuজ্জামান and Gaonkar. So actually, maybe you have any other books, that is Hayes, you have Habiture, most probably you have many books you have, but I have searched and I have not have enough study material from that book. So for that reason, I have considered the Rafikuজ্জামান and Gaonkar. And Rafikuজ্জামান, the chapter name is Memory Organization, and for your Gaonkar, if you consider the processor 8085, your chapter name will be Memory Interfacing Circuit Design. Okay, but only if you study the Rafikuজ্জামান, that will be enough. Now you know that the what is the function of the memory. Memory basically stores the programs and data, and different type of the memory you have. Here I have considered, suppose, cache and primary and secondary. Cache already you have studied little bit, that is mainly internal memory of your processor. So initially it comes external memory, but today's technology, you have this memory you have inside your processor. And mainly this cache memory is designed with the help of static RAM. Static RAM means that that is designed with the help of flip flop, because it has the very high speed. Now next is that main memory. Main memory, mainly we say that RAM and ROM. RAM is random access memory and ROM is read-only memory. So RAM, we can consider the different technology, that is we can consider the static or we can consider the dynamic RAM. But static RAM is very high cost, and where you dynamic RAM, it is low cost. But speed, if you consider, static RAM is very high speed compared to the your DRAM. Okay, and many other issues are there, but whatever it is, you can use RAM for if you may consider the technology that is a static or dynamic. And secondary memory, you know that is a hard disk. Normally you know the secondary memory. Now whatever the memory means that except your secondary memory, main memory, if we consider on that moment, some basic features are common. What are the features? That is some address bus will be there, data bus will be there, power supply and control signal. So three different basic pins or buses you have, or signals you have. First one is that address bus and data bus. Second is that power supply. Third is that control signal. These three type of the signals we are trying to consider for your memory. Now, if you have the RAM, at that moment, you should consider the read and write, both the operations you can do. But for the ROM, you can understand from the name that is a read-only memory. We can read, we cannot write. So for that reason, we don't have any control signal for the writing operation. Okay, so only we have the read control signal for this. And another control signal, that is a chip select. Chip select control signal, it is for RAM and also for the ROM. So from the name also you can understand that chip select means that with the help of this control signal, you can select that particular chip or that device. Now this is the block diagram, one for the RAM, another for the ROM. RAM, here address bus, N bit address bus, M bit data bus, and some control signals it has. So what are these? So sometimes it is called the chip select, sometimes it is called the chip enable. It is the same function. Output enable line or read control line. Okay, write enable line or write. So these are the three control signals we may have in our static RAM. Sometimes it may be happen we don't have the read signal, read control pins, but with the help of the write control pin, we can control the read and write. When WR bar equals to 0, it will be it will be act as a write operation, and when RW bar equals to 1, on that moment we can use for your read operation. So but both the operation it can do if we consider the RAM. Okay, but most of the time we have the three control signals separately, that is shift select line, read control signals and write control signals, and obviously other two pins we have, that is a voltage supply and that is VCC and ground. And for the ROM, already I have told we do not have the right control lines. So, but others line, that is address bus, data bus, we have. Now these are the ICs, but don't feel fear that you have to remember all these things. You do not need remember to all this pin numbers, IC number, and what are this. It is not required to remember. Whenever we'll give some problem, we'll provide all the information. So do not need to remember all the IC name, but you try to understand that these are the available RAM and ROM chip for where we have some pins for address lines, and for some pins for data lines. Okay, now if you have this configuration, how you can compute the size of the memory, because memory size is very important. That means how much data, how much information you can store with the help of your memory. Now suppose that you consider one memory, that memory has address pins, that is a 12, and number of data pins, that is a 8. Now how can you compute the that size, that is 2 to the power 12. That means you can say that one address can store the 8-bit data, and how many address spaces you can have, 2 to the power 12. That means 12 bits if you have on that moment, how many combination is it possible? That is 2 to the power 12 combination is possible. So 2 to the power 12 number of addresses is possible. So one address can store the 8 bit. So 2 to the power 12 number of addresses can store the 2 to the power 12 into 8 bit. So for that reason, we can say size equals to 2 to the power 12 into 8. And 2 to the power 12 into 8, that means 12, you can write 10 plus 2. So 2 to the power 2, that is 4. So 4 and 2 to the power 10 equals to 1k. And 8 means that byte. So you can say that 4kb. This is not the small b, it is a capital B. Now another IC, suppose that is address pin is 16 bit and number of data pins are the 8 bits, 8. So on that moment, how can you compute 2 to the power 16 into 8? So 2 to the power 16, again you can split that part, 2 to the power 6 into 2 to the power 10. Okay, so 2 to the power 6, that is a 64. So 2 to the power 10 is 1k. We can write 64k. And this 8 bit can store one address. That's why 64k capital B. Okay, so in that way we can compute the number of, you can compute the size of the memory with the help of the address pins and data pins. Now, another IC, it was a very special, only we have only single this type of the IC. This is a 21114 IC. We have the, we have 1K, but each address can store the 4 bit. Okay, it cannot store the 8 bit. And for that, if you compute the size, memory size on that moment, it will be 1k small 1k into 4, that is a 4k small b. Okay, it is not the byte, it is a bit. 4kb it can store. Now see that it is a your IC here is 18 pin IC, and you can check that it has the addresses from A0 to A8, A9. So A0 to A9, number pin number 15, consider that is A9, and pin number 5, that is A0. So we have A0 to A9. That means 10 pins are available for address pins. Now, if you consider the control signals, that is a WE bar, you have pin number 10, and you have 8, pin number 8, that is a chip select line. It is a RAM, but check here, you don't have any write signal to control the write operation. Read operation, you don't have any pin, and 2 pins are obviously will be required for power supply. Now for that reason, uh, here what you can do is just see this table I have written here. You select bar, WE bar, mode and status of the bidirectional data bus and power. Here you can see that WE bar, when it is low, on that moment it is a write operation. It is H, that means high, on that moment it is a read operation. So it is your figure, the actual original figure of your IC, but we can we can draw the block diagram that memory in this way. That is A0 to A9, write enable line, chip select line, and D0 to D3, that is a 4-bit data bus. Already I have explained that address bus is always unidirectional and data bus is always bidirectional. So here chip select line, it is required to select the chip. Whenever you want to select this chip, on that moment you have to give the value CS bar to logic value 0. If you give the CS bar equals to 0, on that moment this chip will be selected. Now here it is high, on that moment it will be in high impedance state. That means it is a standby mode. It will be it will be considered on that moment. What is the meaning? I hope you know that that is high resistance, high capacitors. So whenever in your electrical circuit you have capacitor, inductor may be there. So whatever that type of the component, if you consider, on that moment you have to compute the impedance. If you forget that thing, you just compare with your this value with your high resistance. You know that when you have any path or electrical path where you have a high resistance, or always current cannot flow through this direction. So here is the same thing, it is happen here. That is when the high impedance state, it will occur. On that moment this will be isolated from the whole system. Okay, so on that moment that means it is not enable on that moment. Okay, so like it is enable disable, you can say that. So whenever it is high impedance, so on that moment it will not be selected, but it is a 0. That means when it is the low, on that moment if you want to control with the you can control on that moment with the help of WE bar for writing or reading operation. Okay, so this is the 2114 IC or 2114 memory chip, where you have the 10 number of address pins, 4 number of data pins, and you have some control signals W and CS bar, and others also you have no need to consider for this for this design, because in our computer architecture subject we never consider the exact pins and exact control signals, because if we consider everything, it will be more complicated to design. For that reason, minimum or basic structure of memory, basic structure of any processor we have to consider, and based on that we are going to design. We do not consider the details of all the configurations. Because of that, it will be very difficult if we consider all these signals. Okay, now if we want to design, on that moment we should know some basic concepts of the logic device. I hope you know, because already you have studied the digital electronics class. All these components you have studied. This will be modified structure you will study. So decoder, encoder, latch, AND gate, NOT gate, and NOT gate. Okay, these are the circuits maybe required. So I will try to design in such a way so that you can have less number of the logic devices. Now, a little bit, I'll to explain the decoder. Already, you know, that is in inputs. On that moment, it will outputs will be the 2 to the power n. This is the basic input outputs of your decoder, and we have the two ICs, that 74139 and 138 on 14224 and 328 decoder. And already you know that outputs we have the different types. We can use the logic value 0 or active low output lines, or you can consider the active high, that means logic value 1 output for your decoder. Okay, you can design both the type. So there are the two types of the outputs you can consider, and you can design also. So the 74139 and 74138, both the decoder circuit we have in the market. There we have active low output lines, and there is some reason, because what you have seen that chip select line in your memory, that is the active low, and this chip select line is connected to the decoder. Decoder is used to select the different devices, or you can say that can select the different type of the memories, and memory selection is done by your chip select line, and chip select line is basically the active low. So for that reason we use the decoder circuit, that is active low output lines. So now a little bit I want to explain the truth table. See the truth table, 0 0, on that moment y0 bar is 0, others will be 1. So with the help of active low value we can select the devices. Okay, select the device. Now 0 1 for your y1 bar equals to 0, 1 0, on that moment y2 bar equals to 0, others will be 1, and 1 1, on that moment y3 bar equals to 0, others will be 1. So each and every row of your truth table from y0 to y3, if you consider, only one zero value you can have. Okay, you cannot have more than one zero value. Always you have the single zero if you consider from y0 to y3. So obviously with the help of that zero value you can select, or you can identify your device. Same as your previous, we have another IC, that is 74138, and here is also 3 to 8 decoder. It is a normal, if you feel tough to remember everything, so first you try to understand that what is general circuit. What is the general circuit? If it is the n equals to 3, on that way 2 to the power 3 equals to 8. So always it has any circuit, we know that it has some inputs and it also some outputs. So for decoder circuit, if n equals to 3, obviously outputs will be 2 to the power 3. Another importance is that outputs, what we have considered here, that is active low. And so whatever the ICs are available, it just includes some enable lines. So already we have designed one enable lines, but in our market, or for our convenience, we have some ICs where we have the more number of enable lines. For example, here 74138, this decoded circuit, check here, the enable lines are G1, G2 bar, G2A bar, G2B bar, 3 enable lines, or you can say that E1, E2 bar line, or E3 bar line. So 3 enable lines are here. You can say that why is it required more than enable lines? Why is it required? It is very it is very useful if you have the number of address lines of your memory. It is less than the number of address lines of your processor. So when you will design the circuit with the help of this type of device, you can understand why you need more than the one enable line. Okay, so next, I hope you understand this part. This is whatever you have studied in your digital electronics class, that I have explained here. Okay. Now this is the same as truth table. Truth table explained that if any all are 0, on that moment y0 bar will be 0, same as 111, then y7 bar will be 0. So at a time only one device you can select with the help of logic value 0, because uniqueness you can find out from this truth table, that is whatever the input corresponding, that output line will be 0, others will be 1. Clear? Now give some example to you. Today I will not explain the diagram. Little bit I am trying to explain. Next class I will explain the complete design. Today I will not explain the complete design. Today I will just give you the basic concept of the initial part of your design. Okay. Now, please better mute your, who is there? Please better mute your. See that main memory design. I can take one example. That is suppose if you have the 64 KB memory, and with the help of that you want to design 128 KB memory. Okay, RAM you want to design. That you can that you may have another way, that realize 128 by 8 RAM using 264 by 8 RAM chip. Now, so from the given chief, you try to understand first that what are the number of address lines and what are the number of the data lines. Now, memory capacity, what is given here, 64k capital B, that means bytes. 64k bytes, that means we can say that 2 to the power, what we can say, 2 to the power 6 into 2 to the power 10. Okay, 64 bytes that we can represent with the help of 2 to the power n into m. In that way we can write, where n equals to address lines and m equals to data lines. Now if we consider the first part, that is 2 to the power n, that is a 64k. So for this 64k we can write again that the k means that 2 to the power 10 and 64, that is 2 to the power 6. So all total we have 2 to the power 16. So 2 to the power n, if you compare with 2 to the power 16, that means n equals to 16. So you can easily determine the number of the address line. So you have the 16-bit address lines. Another is that by 8. By 8 means that is a 8-bit data lines. Is it clear better? Anyone please explain that?
Could you explain it again, ma'am?
Yeah, I'm telling that your given memory is that 64k. Okay, 64k by 8, or you can say that 64kb, capital B. Okay, so 64k bytes that we have to represent with the help of 2 to the power n into m. This is the size of your memory. So 2 to the power n means that number of address lines, and each address line can store the m bit data. 2 to the power n into m, meaning is that it can store this amount of data it can store. So that I have given, that is a 64kb. So 64kb, how you can write, that is 64k into 8, b for byte, that's why 8 bits. Now first part, that is that represent the address lines 2 to the power n. So that 2 to the power n equals to 64. 64, how you can write 64k, that is a 2 to the power 6 into 2 to the power 10. Okay, so ultimately you have 2 to the power 16. So 16s are the address lines. So obviously if you have the 16 address line, on that moment your address space will be 64k. Clear? Now if you have the address space 64k and each address can store the 8 bits, so how many, what will be the size, your 64k into 8, that means 64k bytes. KB, capital B. Same way I can say here. Here last example I have considered the, I have written the using 264k by 8 RAM, but sometimes it may be happen, that is you have to compute the number of chips you require to design your whole memory unit. Now here given is that 1k by 4 RAM chip, and you have to design 1k by 8. So for this problem, what has happened, given memory is 1k by 4 RAM chip, but you have to design 1k by 8 RAM chip. So for that reason, you have to compute the number of chips required. Number of chips required will be, what is your required size divided by your given size. That means what is the original size of your memory. With the help of this, you can compute the number of chips required. So 1k by 4, what is it can store, and 1k by 8, what it will be stored, both you have to consider, and you divide the value, automatically you can have the number of IC or number of
Ma'am,
memory chip.
ma'am, one doubt. Ma'am, one doubt.
Bolo.
Ma'am, if each address line is storing m bits, then why it is 2 to the power n into m? It should be 2 to the power n into 2 to the power m, because if m bits are being stored, so 2 to the power m combinations we will get, right? For
No,
data.
beta, no. How can I tell you? One address can store, suppose that you have your in your home, you have the 4 rooms you have. Okay, so In one room you can keep some amount of suppose that some food you can store. What about the food? Suppose 4 kg you can store. Okay, one room is there and 4 kg you can store. So 3 rooms are there. So how many? How much you can store?
12.
3 into 4 kg.
Yes.
So address bits and data bits, I can write here. I don't have that tool to write something on the PPT, but you can understand in this way. One address can store the 8 bit, not the 2 to the power 8 combination can be stored. It is true. Okay, that 8 bit, maybe 2 to the power 8 combination bits, but at a time, how many bits you can write? You can write the 8 bits. What about the bits?
Yes, ma'am.
Understood?
Yes, ma'am.
One
Understood.
address, understand, what?
Yes, ma'am. Yes, ma'am.
Okay. Next class I will explain with the help of figure. Okay.
Okay, ma'am. Okay.
Okay. Now here memory chip is that 1k by 4. So 2 to the power n by m, 2 to the power n. So 1k means that 2 to the power 10. So 10 number of address lines you have. And 4 bits if you are consider the data bits. So m equals to 4. Okay. So 1k by 4. And you have to design 1k by 8. So you need the 2 memory chips. Now another thing you have to know, that is also processor. If you want to design with the help of processor, on that moment you have to know the configuration, or you can say that little bit architecture of the processor. But no need to remember the processor name and everything, but you have to know the this type of the possibilities of the architecture you can have. For example, 8085 microprocessor has 16-bit address bus, while 8086 processor has a 20-bit address lines. Here you have the 8-bit data. In 8085 you have the 8-bit data bus, and in 8086 you have the 16-bit data bus, and some control lines have. So in your exam we will provide all the configuration. We will not mention the exact processor architecture. Okay, whatever the processor architecture, and we will give some configuration. Based on that you have to design the memory unit. Okay, so today I want to stop here. Next class I will explain how you can design with the help of these configurations. Clear, better? Do you have any question? You can ask me. Okay, so I can stop here.
Thank you, ma'am.
Okay, better.
Thank you, ma'am.
Friday I'll take your class.
Okay, ma'am.
Okay, ma'am. Thank
Thank
you.
you, ma'am.
Okay, better.
Thank you, ma'am.
Okay, better. You can leave. I forget to record. I don't know